This rocket engine didn't come off an assembly line. It came out of a printer, layer by layer, from a pile of metal dust. Today, we're breaking down how 3D printing is rewriting rocketry, how it works, who's flying it, and why it changes everything about getting to space.
For decades, engines like the shuttle's RS-25 were plumbing nightmares. Thousands of parts, miles of welds, years of painstaking assembly.
And every single weld is a potential failure point that has to be inspected, x-rayed, and certified. That's why great engines cost millions. Metal 3D printing flips the script. A laser sweeps across a bed of fine metal powder, fusing it solid exactly where the design demands. Then the bed drops by less than a hair's width, and it happens again. Thousands of layers later, a combustion chamber grows out of the dust. SpaceX printed the SuperDraco's chamber from Inconel, a superalloy that shrugs off extreme heat. Hundreds of parts became one solid piece. 8 SuperDracos powered the Crew Dragon's escape system. If a rocket fails, they hurled the capsule and its crew to safety in about a second. Even the mighty RS-25 got the treatment. Its newest version swaps dozens of welded assemblies for printed parts, slashing cost and build time. Even Raptor, the monster engine behind Starship, is loaded with printed components buried deep in its plumbing. Then a company from New Zealand went all in. FLT-LAB's Electron flies on Rutherford engines that are almost entirely printed. Chambers, injectors, pumps, and valves, all of it comes off the printer in about a day. A single day for a flight-ready rocket engine.
Rutherford ditched traditional turbo machinery too. Battery-powered electric pumps feed its fuel, a first for any engine reaching orbit.
And NASA is pushing even further. Its printed rotating detonation engine rode a continuous wave of explosions for 251 seconds. And that's the real revolution. When an engine takes days instead of years, engineers can test wild ideas, fail fast, and fly the winners. So here's the recap. Printing means fewer parts, faster builds, lower costs, and shapes no machinist on Earth could ever carve. Next time you watch a launch, remember, some of the hottest, highest stress metal on that machine started as a pile of powder. If that blew your mind, subscribe for a new aerospace deep dive every week. Tell me in the comments what should get printed next, and send this to someone who thinks 3D printers only make toys.